Based on that, we can create millimeter accuracy 3D models. And then we can take measurement out of these 3D models. That's why it's really focused on getting popular in maritime archaeology first. But nowadays, many terrestrial archaeologists and other researchers start using this software. Okay, photogrammetry is very different from other scanning because it's based on the photos. It has really great texture. So 3D models going to be very photorealistic. And then these softwares, photogrammetric softwares, are many cases made for survey. So if you have XYZ coordinate, or if you put scale bars around the site, then you know the distance. If you put non-distance or coordinate onto the created 3D models, your 3D models follow the accuracy. If you have the coordinate system or like non-distance, which is millimeter accuracy, your 3D models is going to be millimeter accuracy as well. Okay, now I will show you some animations of what we did 2 months ago in Saipan, which is the Operation Fraser project and the ship's discovery led by Dr. Jennifer McKinnon and Tony Carroll. So this is example of photogrammetric model. And also it can cover larger site. Okay, let me talk about this, how it works in terms of this technology. So it uses depth perceptions. This technology was developed during 80s and 90s by computer scientists. When AI, artificial intelligence, getting a popular idea, so they needed to put some technology for robots. Robots have to understand surrounding structure immediately. So they needed to create 3D environment around their robot itself. So if you close one eye, you don't have any depth perceptions. But if you open 2 eyes, suddenly you have depth perceptions. Because your eye has angle of views, then if you have 2 eyes or 2 cameras, in this case, in different positions, so 2 images, your camera shows different images from different angles. That creates the depth, and your brain calculates these differences and compose 3D structures. And 3D photogrammetry is an idea that if you have 1,000 eyes surrounding the object, then you have complete depth perception. And using this depth perceptions, the program can recreate the structure which is 3D. Then based on the photos, it creates texture and place that texture on top of 3D models. That's how 3D photogrammetry works. And good thing is it uses just photos. So nowadays, of course, you can create the 3D based on underwater cultural heritage or underwater object. And of course on land, and many researchers doing aerial photogrammetry, which is using drones. Drones are getting cheaper and easy to manipulate. So in that case, mostly everything, as far as you can see, you can create 3D model. And why it's important in terms of creating a 3D model. Because we have cultural heritage, which is our common heritage, but we don't know if tomorrow we have that same. So we have a lot of imminent problem. So East Asia, Middle East, many cases, Taliban and ISIS, religious extremists, are destroying like cultural heritages on purpose. And of course, underwater cultural heritage, we have problem with treasure hunters, looters, and also even like safe areas. We have tsunamis, earthquake, and fire, and many touristic places. We have tourists. They want to leave scratches and destroy and take some small stuff as souvenirs. The point is, we don't know problem. We don't know how long we can have our common heritage. And end of the day, everything gonna disappear. So we have heritage right now, but in 1,000 years, we gonna lose everything. And also like everything going to change. So we have cultural heritage right now, but maybe in 100 years, we have, but it's partially destroyed or weathered. So what we can see is what our children and our offsprings can see is different from what we have right now. It's really important for us to live and to protect data of cultural heritage to next generations. And photogrammetry use photos. So technically speaking, as far as it's on land, you can use iPhone to create these 3D models. And you need a software, but it's not super expensive. For example, if you need a laser scan or other scanning system, it's costs like $100,000. But this one, as far as you are under education system, it's 500, and commercial use 3,500, which is many cases affordable if you compare that price to other the laser scan apparatus. So here, what we have to think about is that if you have accurate 3D models, how we gonna use it? And from next slide, I'm gonna introduce like the underwater cultural heritage that we recorded in Saipan 2 months ago. But during the presentation, I want everybody to start thinking about if you have this technique. So if you have these 3D models in your site, so all cultural heritage belongs to the people. So it's like I'm here to teach this technology to young students, and I may come back to teach again for other researchers. So definitely, you're gonna have this technique, or if you wanna learn, so we can teach. We can provide teaching experiences, like field school like thing. So the point is, I want everybody to think how you wanna use 3D models. So there is a technology to create 3D models, but the important thing is how we're gonna use it. Okay, 2 months ago in Saipan, we had some project, Operation Foragers, which is to protect and manage cultural heritage. So following me, Vicky, the conservation specialist, talk about like what they did. But the point is, every 5 years, we're gonna go back and create accurate 3D models and corrosion analysis. And every 5 years, we analyze how cultural heritage sites are changing. Then, so we clearly understand that how cultural heritage sites are degrading and changing, and how long it's gonna last. In that case, as far as we know clearly what's going on cultural heritage, we can use 3D model as kind of monitoring purpose. So based on changes, we can clearly construct good management plan. That's in this project how we use the 3D models. First one is airplane Jake. And from now, I also want to show you so this website is called Sketchfab. You upload 3D models and everybody wants to look at this model can visit this site. It's like a YouTube, but for 3D model. And it's already uploaded to the online public. So if you type ECU, East Carolina University, Maritime Studies, you can go to this page. So Jake was Japanese airplane, and that was most used type of airplane by Japanese Navy. And of course, if you take cameras beneath the wing, you can take things beneath. The point is, as far as you take photos, the structures are shown in the 3D. The images, you can create 3D model. Next one is Avenger. It's an American torpedo bomber, and it can carry like 700 to 726 kilograms, and that was on top of coral reefs and upside down. So you can see like the upside down chicken. And actually, many marine biologists contacted me because they want to use that technology for their coral reef studies. It tracks the growth of coral reef, even though it's like centimeters every year. But as far as you can do 3D modeling right, you can create two different models from this year and next year, and you can compare. And there is a software that we can compare two different models by by color and the quantity data. And Mariner was a US flying boat, and it took only 2 dives, total like 1 hour and 15 minutes. So like 75 minutes underwater, you can create this 3D model. And what was interesting is that so we had site plan left by archaeologists, but so many details are kinda off because that was created by humans. So many cases that site plan or record left by archaeologists has minor mistakes. I still think that creating site plan by archaeologists is really important because it's human interpretations. But sometimes it has a mistake. So my recommendation is that use this as a template. So we can create a very simple site plan out of 3D models. Then archaeologists use this as a template to update their additional information. Next one is my favorite, Emily. It's Japanese airplane, and it's 4 engines, huge Japanese aircraft. And here, this site is very huge, and you can see numbers here, which is called annotations. And if you click, you can operate, and each annotations you can put the explanations. So this 3D model can work as 3D map. This took 4 dives, approximately like 2 hours, 120 minutes, and then you can create this model. Processing hour of each images, like each models, basically like 24 hours. So if you go to dive and come home, then put every images in the computer and start processing. Then next day, by the time you come back from the diving, you have 3D models. So it's really, really fast. And vehicles. So we had 3 Japanese landing craft. It's called Daihatsu. They carry the tanks and troops from sea to the beaches. Even rigs has small objects or like bar-like object, it's really can get details. And LBT, amphibian, American cargo carrier. And then Japanese subchaser. So this distinctive, like a very sharp bar, is designed to chase submarines. So that was originally like the whaler, so it's designed for speed. And also important things about this 3D model is that the bow part was taken by based on photo, and bottom part, the body part, are the 3D model based on videos. So we can use video footages to create 3D models. When you have videos, you can extract still frames. In that case, like in short time, you can get larger area. And these 3D models, 9 of them are done in 2 weeks and 15 days, 11 days of like diving operations. So it's also very quick. If you can do recording very fast, it's much cheaper because we don't need to pay divings and divers. Okay, now the important thing is how we want to use it. So the heritage monitoring is that we are applying for the Saipan case studies. We're going to use these 3D models to monitor the site, to track the changes through time, to construct proper the management plan. But also that like Guam, Saipan, and Southeast Asia. So we have to think about how we're going to use that for local communities. Because cultural heritage belongs to the local communities. And many cases, so many divers enjoy the site, and we cannot avoid that. But like, so how we gonna use the cultural heritage properly? So we have to make the cultural heritage more like proper museum. If we just leave the cultural heritage, then like divers don't think it's important. But if we have historical researches and create 3D model and say this is underwater museum, then suddenly it's more like a cultural property. So we can appreciate the common heritage together. And these are kind of examples how we're gonna use 3D models of cultural heritage properly. So CG animation is something that I shared at the very beginning. So these are simple flying camera animations. So we can fly cameras everywhere around the 3D models. So it's more like a visual tour, the virtual tour of cultural heritages. The point of underwater cultural heritage is that not many people have a diving license. So only way to access the site is you have the diving license. And many cases, like Europe and Japan, you need a permission to reach the site. If you don't have permission, you end up in jail. So many cases, the access to the cultural heritage is limited. Then now we can use these 3D models to use that to share our common knowledge with the general public. And also visual museum is the sketchpad that I was just using. So once we upload 3D models, everybody wants to see, can enjoy the cultural heritage. And also this is digital data, so we can just simply print out. And also posters for museums or some cultural events. And also this is digital data, and once you have animations, it's really easy to convert it to hologram. And that, of course, virtual animations is another application for the general public. And the bottom one is like recently I've done with Kyushu National Museum. Actually, exhibition opened like 5 days ago, which is, so we have the photogrammetric data of one shipwreck site. And then we put that data into mechanical mill, which is the drill that carve out materials based on 3D data. So in this case, it carved out foam board, which is really cheap material. But we can create a one-to-one replicas. And we are planning to use this one-to-one real-size replica to educate the young people. So how to record the shipwreck site. So many cases, professor doesn't want to bring students to the cultural heritage site, because within shipwrecks, if somebody touches, it's break. So people who do recording need a certain skill of diving and already have to know how to record. So it's kind of risky to bring first-time students to the cultural heritage site. But using these cheap replicas, we can train students inside the museum on land, so it's safe. Then once we teach how to record, then we can bring students. So we can use these 3D models as a training facility. And also we can create a high resolution photo mosaics and simply print out and put on the floor. Then you can enjoy the scale of shipwreck. So many cases, you cannot feel the size of shipwreck until you actually see. But if we put the high resolution photos on the ground, everybody can enjoy the actual size of the ship. And so this is, monitoring. If you have two 3D models from different days, we can put on the software and software tells differences. So we can track differences. So if we have 3D model from this year and next year, then we can see what is differences by color and the quantity data. And also this technique, the photogrammetry, we just need images. It means I don't need to be here. Professor doesn't need to be here. So we can cooperate with local divers and local peoples. If they know how to take photos properly, then they can take photos and send 3D model or images to archaeologists to process. So it's more like interactive. We can protect and monitor our common heritage as a group. So it's more like not only archaeologists, not only like scholars, but based on the divers and local communities, we can monitor and protect our heritage together. So these are possibility and potential of 3D model and photogrammetry. And I'm really happy to be here to share how to do this with students here. Thank you.